Welcome to our session on mastering data insights through summary statistics in SPSS. This presentation is a step-by-step guide tailored for researchers, aiming to equip you with the skills for that crucial first look at your data. Our goal is to transform raw numbers into actionable economic insights, starting with the fundamental principle that data is far more than just figures. It's a story waiting to be discovered and told. For example, before diving into a complex consumption model with household expenditure data, you first need to understand the basics, average income, or even spotting data entry errors like negative expenditures. This initial, critical step is precisely what we'll be covering today. So, why is this first look so indispensable? Let's explore the common blind spots researchers face when they skip this initial step. Before we dive into any complex statistical analyses, it's absolutely critical to validate the quality of your raw data. This initial check, often called a first look, is your primary defense against the garbage in, garbage out problem, ensuring the integrity of your results. The frequencies procedure is instrumental here. It helps us systematically achieve three key objectives. First, we determine typical values by examining measures of central tendency and dispersion, which give us a sense of the data's core characteristics. Second, we can check crucial assumptions about our data, such as sample size and the underlying distribution of variables. Third, and perhaps most importantly, it acts as a robust quality control mechanism. This allows us to quickly identify glaring issues like missing values or obvious data entry errors, such as a reported age of 150, which would severely skew any subsequent analysis. For instance, finding an age of 150 immediately flags an extreme value that needs investigation. Ignoring such an outlier could drastically impact your average age, leading to misleading conclusions. Now that we understand the why, let's discuss how. The correct method depends entirely on the nature of your data. The type of variable you have dictates the appropriate statistical method. For nominal variables, like gender or region, we focus on the mode and frequency counts. For ordinal variables, which have a meaningful order but not a consistent interval, such as Likert scales or rankings, cumulative percentages are most insightful. For scale or continuous variables, like salary or age, we can use a full suite of statistics, including the mean, median, standard deviation, skewness, and kurtosis. If you're analyzing customer satisfaction on a scale of 1 to 5, an ordinal variable, calculating the mean might be misleading. Instead, looking at the cumulative percentage, for example, 80% of customers rated us 4 or higher, provides a much clearer and more accurate insight. When looking at these outputs, especially for categorical data, you'll often see two types of percentages. It's crucial to understand the difference between them. SPSS outputs present two types of percentages, percent and valid percent. The standard percent takes the frequency of a category and divides it by the total sample size, which crucially includes any missing data. You can see its formula is frequency over total n multiplied by 100. However, for a more accurate reflection of your data, we turn to the valid percent. This is calculated by dividing the frequency by only the valid number of cases, explicitly excluding missing data. Its formula, frequency over valid n multiplied by 100, highlights this key difference. For final analysis and reporting, it is a critical distinction to always use the valid percent. The regular percent dilutes your findings by including those missing values, which can lead to an underestimation of a category's true prevalence among respondents who actually provided an answer. For example, if you have 886 responses out of a total, the percent might show 99.7%, but the valid percent corrects this to 100%, accurately reflecting the proportion among those who responded. Before proceeding with frequency analysis, it's crucial to acknowledge and meet three core assumptions. First, we assume independence of observations. This means each entry in your dataset must be unique, like having one subject, one vote. If one person's response is accidentally entered multiple times, it violates this assumption, artificially inflating counts and biasing your results. Second, we must always respect the measurement level of our data. While SPSS is a powerful calculator, it is not a statistician. It will happily compute a mean for nominal data, such as an average gender of 1.5, but such a result is statistically meaningless and nonsensical. It's up to you, the researcher, to recognize these pitfalls. Finally, we must consider sample size. For the analysis to be meaningful, each category within your variables should have sufficient counts. A good rule of thumb is that the expected frequency in any given category should be at least 1, and preferably higher for more advanced statistical tests. Once we've checked these assumptions and generated our statistics, we can then confidently interpret their economic meaning. In economics, the normal distribution is often our ideal assumption for many statistical tests, characterized by its symmetry, where the mean, median, and mode are all equal. However, real-world economic data frequently deviates from this ideal. For example, wages or income often exhibit positive skewness, meaning there's a long tail on the right side of the distribution. This visually represents income inequality, where a small number of high earners pull the average upwards. Beyond skewness, we also analyze kurtosis, which measures the tailedness of a distribution. A distribution with high kurtosis, appearing taller and with fatter tails, indicates a greater likelihood of extreme outlier events. In finance, these are sometimes referred to as black swans. Identifying these characteristics early is crucial, as they dictate which hypothesis tests are appropriate for your analysis. For instance, in stock market returns, high kurtosis signals a non-trivial probability of a very large gain or a significant market crash, information a simple standard deviation wouldn't fully capture. To access the frequencies procedure in SPSS, you'll navigate through the main menu. The path is Analyze, then Descriptive Statistics, and finally, select Frequencies. A common question is, why not use the Descriptives command instead? While Descriptives is useful, it's primarily designed for comparing continuous variables, especially when you want to generate z-scores. The Frequencies command is superior for our purpose because it provides detailed frequency tables, which are essential for categorical data, and offers more options for statistics and charts. For example, if you need to report the exact number and percentage of male and female participants in your study, you must use the Frequencies command. Descriptives will not produce this categorical breakdown. Once you've clicked on Frequencies, a dialog box will appear, where we need to configure our analysis. When configuring the Frequencies procedure, you'll work with two main subdialogues. First, in the Statistics subdialog, you'll select the relevant measures. For continuous or scale variables, it's customary to include the mean, median, mode, standard deviation, skewness, and kurtosis to gain a comprehensive understanding of your data. Secondly, in the Charts subdialog, ensure you select histograms. Crucially, always remember to check the box for Show Normal Curve on Histogram. This visual overlay provides an immediate, intuitive goodness of fit test. It allows you to quickly assess how closely your data's distribution aligns with a normal distribution, which is a fundamental assumption for many subsequent statistical analyses. This instant visual feedback is invaluable for spotting deviations or potential issues with your data's distribution. Our case study begins with analyzing employee wages, and the foundational first step, even before any statistical tests, is thorough data preparation within the Variable View tab of SPSS. This is crucial for ensuring the integrity and interpretability of our analysis. There are two primary actions to take here. First, always ensure the measure type is correctly assigned for each variable. As you see, gender should be nominal, education level would likely be ordinal, and salary is clearly a scale variable. Misclassifying these can lead to inappropriate statistical calculations. Second, and equally important, you must define your value labels before you run any analysis. For example, mapping the numeric code 1 to male and 2 to female for the gender variable. Skipping this step means your output tables will only display confusing numeric codes, forcing you to constantly refer back to a codebook to understand what 1 or 2 actually represents. Properly labeled data makes your analysis clear and immediately interpretable. Once the data is meticulously labeled and correctly defined, we can confidently move on to executing our analysis. For our second step in the case study, focusing on execution, it's crucial to always use the Paste button rather than OK after configuring your frequencies dialog box in SPSS. Clicking Paste will open the syntax editor and automatically generate the command syntax for your analysis. This creates a powerful, reproducible script of your work. Saving this syntax file is a best practice because it documents every step you've taken, allowing you or other researchers to instantly replicate your analysis or verify your methods. It also makes it incredibly easy to debug or make minor adjustments to your analysis without having to remember every single click and checkbox you selected initially. When you receive your SPSS output tables, it's crucial not to simply copy them into your report. Instead, you must actively interpret and extract the narrative hidden within these numbers. A particularly insightful column to focus on is the cumulative percent. This running total is incredibly useful, especially when dealing with ordinal or categorical data, as it provides a progressive summary of your distribution. The cumulative percentage indicates the proportion of your dataset that falls at or below a specific category. This allows you to quickly pinpoint where the majority of your data points are concentrated and helps in identifying significant cutoff points within your variables. For instance, in this ethnicity table, the cumulative percent for white is 89.5%. This immediately tells us that nearly 90% of the employees in this sample belong to this ethnic group or those listed before it, offering a much deeper understanding than just the individual percentage for each category. Visual confirmation of your data's distribution is absolutely mandatory. While summary statistics like the mean provide a quick overview, they can often be profoundly misleading on their own. Consider this classic example. A mean salary of $50,000 could describe a group where everyone earns exactly that amount. Alternatively, it could represent a scenario with 49 unemployed individuals and one person earning $2.45 million. The average is identical, but the underlying economic reality is drastically different. Only a histogram, like the one displayed here, can truly reveal the story within your data. It illustrates the shape of the distribution, highlights the central tendency, indicates the spread, and clearly points out any potential outliers, such as the wealthy earners clustering on the far right of the salary distribution. This visual insight confirms a positive skew and the presence of individuals earning over $110,000, details a single mean could never convey. This crucial step completes our walkthrough of the frequencies procedure. Thank you for joining us today. We've explored